So welcome everyone. Today we are going to see about combinational circuits. So under which we are going to see adder and multiplexers. There are different types of combinational circuits: adder, subtractor, and multiplexer, demultiplexer, encoder, decoder, parity checker, and parity generators. So we are going to see in this video only about adder and multiplexer. So generally the combinational circuit is also called as a combinational logic circuit, is a digital electronic circuit whose input is determined by present input only. So look at this block diagram. So where we will be having multiple we are having multiple input and multiple output. So this input and output based on the combinational logic circuit that we are going to design. So if you consider half adder, there will be two input A and B, two single bit binary input, then the output will be, the possible output will be sum and carry. So if you consider a full adder, there will be a three single bit input and the it will produce the output sum and carry. So the input and output is determined by the logic that what we are going to design. So we are going to consider a half adder. So it is an arithmetic combinational circuit designed to perform addition of two single bit input. So if it is a full adder, it is used to perform the addition of three single bit inputs. So it contains two inputs and produces two outputs. The two outputs will be sum and possible output will be sum and carry. So in generally inputs are called adjoint and the added bits and outputs are called sum and carry. So look, this is the block diagram of half adder where we are having two input A and B, and the sum will be a possible sum, output will be sum and carry. So this is the truth table of half adder. As already I have said, there will be a two input. So if there is a two input, there will be four combinations 0 0 0 1 1 0 1 1. So if we are adding these two bit, we will be getting sum and carry. There will be only two possibility, one is sum and carry. So if you add 0 plus 0, there will be a possibility of sum and carry. So the input will be 0 and 0, the output will be also 0, sum will be 0 and carry will be 0. So if you add 0 plus 1, there will be a sum 1 and carry 0. For the input 1 0, sum will be 1, carry will be 0. For the input 1 1, so if we are adding 1 plus 1, so we will be getting the output as 1 0. So in decimal it is 2. So if we are adding 1 plus 1, it is 2. So the 2 is represented in binary 1 0. So it is, this LSB bit is called sum, this MSB bit is called carry. So carry is 1, sum is 0. So after that we have to find the Boolean expression for the output sum and carry. So here the output is sum and carry. So this is a very simple circuit. We can write the expression as it is from the truth table itself, or otherwise if it is a complicated combinational circuits, we have to go for K-map or Boolean algebra to reduce the expression in order to get the reduced expressions. So here the sum, in the sum column we are getting output here and here. So consider this output, the corresponding input is A is 0, B is 1. So we can write sum equal to A bar B plus, so the next output we are getting here, the corresponding input is A1 B0. So we can write A B bar. So this is the this looks like a XOR gate. So we can write A, in simplified version we can write A XOR B. So carry, we are getting only one output in the carry. So here the corresponding input is A is 1, B is 1. So we can write carry as A and B. So next we have to draw the logic diagram. So there is two input A and B, A and B, A and B. So the sum is A XOR B. The one input is A, another input is B. So we have to give the input to XOR gate. XOR gate. So it is sum. For carry, the two inputs we have to given it to the AND gate. So it is a carry. So this is the combinational circuit or a logic circuit for the half adder. So if you design or implement this digital circuit in digital trainer kit, and will be it will be working like this truth table. So likewise, if it is a full adder, there will be a 3 input, another there will be added 1 input. This, if we are getting carry, that the carry will be added with the input. So their possible output will be sum and carry. So you can try the design of full adder. So next we will see the multiplexer. So multiplexer is a combinational circuit that has many input lines and single output. So and there will be a selection line. So based on the selection lines, the input will be connected to the output. In general, there will be a 2 power n input, and there will be a n selection lines. So there will be a 2 power n. If it is a 2 power n input, so this power is the selection line. So and the output will be, there will be only one output. So the multiplexer mainly is used to increase the amount of data that can be sent over a network, so within a certain amount of time and bandwidth. So this is the block diagram of multiplexer. So where their input is 2 power n. So this is the n is a selection line. There will be n selection line and one output. So if you consider 4 cross 1 multiplexer. So this is the input, 4 input and 1 output, and the 2 can be represented in 2 power, can be represented as 2 power 2. So this 2 is the selection line. So and there will be 2 selection line. So based on these 2 selection line, the input will be connected to the output. So mainly it is used in communication applications. So in generally consider mobile communication. So the working of mobile communication is, suppose we are making a call to the destination, it will connect it to the local mobile control station. So there will be a transmitter and receiver. So in a transmitter there will be a 12 channels. So each channel will be allowing 8 calls. So totally at a time the transmitter will be allowing 96 calls. So someone, if you are making, we cannot sure that at a time there will be a multiple calls. There is a possibility that 1000 calls, 10,000 calls, so we can't say that. But the transmitter will be allowing only at a time 96 calls. Suppose someone is calling 97, then 98, 99. So at the time the multiplexer plays a major role to select which call we have to select next. So that is the main role of multiplexer. So this is the 2:1 multiplexer. So to 2:1 multiplexer, there will be 2 input, 1 selection line and 1 output. So this is a selection line named as S0, and input is I0, I1, and output Y. So if the input is, there is a 2 input, so if there is a 1 selection line. So based on these selection line, the input will be connected to this output. If S0 is 1, S0 is 1, S0 is 0, the input I0 will be connected to output. If S0 is 1, the input I1 will be connected to this output. So if S0 1, I0 will be connected to the output. If S0 is 1, I1 will be connected to the output. So, we can write in expression, Boolean expression. So, S0 bar, there will be only one output. So, S0 bar I0 plus S0 I1. So, this equal to the output Y. So, this is the 4:1 multiplexer. So, as we have discussed the function of multiplexer. So, therefore, for 4:1 there will be a 4 input, 2 selection line and 1 output. So, based on these selection line, the input will be connected to the output. So, if it is 2 selection line, there will be 4 possibility 0 0, 0 1, 1 0, 1 1. If it is a 0 0, then I0 will be connected to output. I0 will be connected to the output. If it is a 0 1, then I1 will be connected to the output. I1 will be connected to the output. If it is a 1 0, then I2 will be connected to the output. I2. If it is a 1 1, I3 will be connected to the output. It is a 1 1, I3 will be connected to the output. So, the expression, we can write the expression S0 bar, S1 bar, I0 plus S0 bar. So, the next selection line input is 0 1. So, if it is 0 1, so S0 bar, S1 I1 plus next input is 1 0, selection line is 1 0. So, we can write S0 S1 bar I2 plus next input is 1 1. So, we can write S0. So, selection line is 1 1, the I3 will be selected to the output. So, it is I3. So, this is how the multiplexer will work. Thank you.